Hey guys, welcome back. We are now on to activity 14, and the objective of this lesson that we're going to be working on today is we're going to be looking at graphing systems of linear equations. And today, the purpose that we're going to look at, the learning target we're going to look at, is to understand that solutions to systems of linear equations correspond to the point of intersection of their graphs. That's the first one. The second one is we're going to use system of linear equations to solve real-world problems. So the situation we have here today, it says Chip decided to upgrade the landscaping in his yard. He bought a 10-gallon mesquite tree and a 50-gallon desert willow and planted them. After 1 year, which is key, 1 year, he was shocked at the growth of both of the trees, so he measured their heights. The mesquite was 5 feet tall, and the desert willow was 8 feet tall. The next year, he measured again and found that the mesquite tree was 6 feet and 6 inches tall, and that the desert willow was 8 feet and 8 inches tall, which is interesting enough. I'm going to kind of separate these out a little bit by color so you can see that at first, after year 1, the mesquite was 5 feet tall, and then it went up to 6 feet 6 inches tall. And the desert willow was 8 feet tall, but the second year it was 8 feet and 8 inches tall. So number one, it wants us to fill in the table as much information as you can. So first of all, notice that this is in inches and in inches. So we need to take at year one, the mesquite tree was 5 feet tall. So we know that in 1 foot there is 12 inches. So it's going to be 12 times 5. Let's see what 12 times 5 is. 5, that's 10. Carry the 2. That'd be 60. So after year 1, the mesquite tree was 60 total inches. Oops. Then year 2, it was 6 feet 6 inches. So that's another 12 plus 18 inches. It grew in 1 year. It grew to 12. It grew up 18 more inches on top of that. So let's see. That would be 78. Okay, so that's what the information we have there. I want you to press pause. I want you to use this information in orange to fill in the table for what you see right here for the willow. Fill in years 1 and years 2 using this information. Keep in mind that 1 foot is equal to 12 inches. Press pause and fill that in now. Okay, eventually we're going to graph this, but first let's do number 2. Let's do number 2. It says if the tree grew at a constant rate of change for the first 2 years, how tall were they when Chip planted them? So let's see, if it was a constant rate of change, if this continues to go up by 18 inches, then year 3 would have been 96. Year 4 is 114. Year 5 is 132. Year 6 is 150. Year 7 is 168. So going back to when it was originally planted then, notice that this is going up by plus 18 the whole time. So if we go back the other way, we're really just subtracting 18 from 60 to figure out what it was in year 0. So 60 minus 18, that would be 42 inches is what it was originally. So to graph this then, at 0 it'd be 42. Let's see if this is 24, so 42 is about right there. This would be year 1. So year 1 would be 60. That's 75, so 60 is about right there. Year 2, 78, so just above that. Year 3, 96, so just below that. Year 4, 114. So you're just going to keep noticing that this is increasing at a constant rate. Year 5, 132. It's going to keep increasing at a constant rate. Year 6, 150. Oh, that's the first easy one, has a corner. Year 7, 168. So that's what our first line would look like here. Looks something like that. And it goes through all the points. I want you to press pause and I want you to fill in the rest of the table and then graph the line for the willow tree and what that would look like. Press pause now and try that on your own. Okay, hopefully for the willow tree, what you got then for the willow tree would have been originally 96, 104. The original height then would be 88 because you would notice that it's going up. The increase that it's going up by each time is 8 inches. It's going up by plus 8 on our side. So if you keep filling that in, you'll see what it looks like. Notice that the mesquite starts much, much higher. Starts much higher than the willow tree starts much higher, 88. Year 1 is 96. Year 2 is 104. So it starts larger, but it's not growing at the same rate. It's not exactly growing at the same rate. So we go to 104, 112, 120. I'll let you finish the rest of that. But you can start to see where this is going to happen. So year 3 is 112. Year 4 is 120. Year 5 would have been 128. Year 6 is 136. And now notice that this is almost getting there. It's no longer is it taller. It is now actually shorter than the last one. Which is really interesting. So we graph these points. I'll let you finish the rest of those, but when we graph these points, you'll see that while the willow tree started taller, it got actually shorter as it went. Let's look at number 3. Let m be the height of the mesquite tree in inches. Write the equation to represent this. Well, we remember, everyone, we should remember that y is equal to mx plus b. So we need to figure out the slope. The slope of the mesquite, remember, it goes up by plus 18. So really, we're going to use m here, though. So m is equal to our slope of 18, x plus our starting point. So remember, when the mesquite was planted, it was 42 inches. So it's plus 42. That's our first equation. I want you to press pause, and I want you to try to go ahead and do number 4 on your own. Write that equation, use the slope, use the y-intercept, and write that equation. Press pause. Okay, now for number 5, when will the two trees be the same height? Well, that point, ladies and gentlemen, is actually right about in here. You'll notice that it's in between 4, and this is 5 here, and it's in between 5. It's at that point right there. So it's about approximately, about 4.5 years after it was planted. That's when the two trees, approximately when the two trees will be the same height. Looking on the back side, we're going to go ahead and graph both of these equations here. We want to graph these two equations and find the solution. So this says equations m and w can together be described as a system of linear equations. So these two equations that were on the front side are a system of linear equations. It's where the two lines intersect. This right here is what we have to learn today. The intersection point is the solution to this system, to the solution. So here in the next number 6, we're given 2 more equations. We're going to graph these 2 equations, and then we want to find the solution, which is the intersection point of these 2. So I'll do number 6, then I'm going to have you guys go ahead and do the next one, number 7, on your own. But for number 6, notice we have y is equal to negative x minus 2. So really this is like negative 1x minus 2. So again, keep in mind, y is equal to mx plus b. If we have our slope and we have our y-intercept, then we can graph this line. So starting with b, our b in this case is negative 2. So our y-intercept is going to be right here at negative 2. And our slope is negative 1, or negative 1 over 1, which means we go down 1, right 1, down 1, right 1, down 1, right 1. All the way. When we run out of room, we'll go up 1, left 1. And we're going to continue this trend, and you should be able to notice this graph. I'll plot these points. I'll go ahead and graph these out. And you can see this is our first line. So now we have to graph the second line to find the solution of this system. We have to graph the second line. So the b in this case is the plus 3. So this one starts at plus 3. And you'll notice this is a slope of 2 over 3. So rise 2, run 3 point. Rise 2, run 3 point. Run out of room, so now we got to make them negative. Negative, we'll go down to left 3. Down to left 3. Down to left 3. Graph this line. Boom, goes through there. And what you'll see, that our point of intersection is this location right here. Both of these points have the coordinate -3, 1 as the solution to this system of equations. So it's where these two would equal. In the case earlier, it's where the two trees are the same height. This one is where our two equations, our two graphs meet. That is called the solution to a system of equations and is the point of intersection. I want you to do number 7 on your own right now. Remember, y is equal to mx plus b. So you're going to graph both of these equations. Use your y-intercept, which would be 5 and 1. And they're going to use your slope, which in this case would be -1 and 1. Good luck when you get done. Do your IXL to get full credit for the day. Thank you all.